Welcome, dear friends. Tonight, let's cast our eyes upwards to the boundless expanse, where for eons, a star named the Sun has been the fiery heart, and where planets gracefully waltz around it. Up there, the void is not emptiness, but a magnificent canvas where galaxies, meteors, and auroras paint the tapestry of time. Close your eyes. Imagine you are a speck of light, effortlessly drifting through the weightlessness of space. All around you is the chill and the silence, yet in the distance, our home star, the Sun, shines bright. We're about to embark on a sweeping journey across our solar system. We'll peer into its very core, glimpse the inferno of Venus, explore the unique pairing of Earth and the Moon, soar above the furious storms of Jupiter and the majestic rings of Saturn, and finally reach the icy fringes to touch the enigmatic comets. So, settle under a blanket, release the day's anxieties, and let my voice be your guide through the quiet of the night, leading you far towards the stars and to the very essence of existence. We begin. The solar system is an oasis of life set in the frigid cosmic ocean. By the universe's standards, it seems tiny, but if we imagine a scale where the Sun is the size of a soccer ball, the Earth would be a pinhead orbiting about 25 meters away. And even on this scale, the nearest star would still be over 7,000 kilometers distant. The Genesis, a star is born. Our system's birth story began about 4.6 billion years ago. To put that in perspective, if that entire span were compressed into a single 24-hour day, humanity would only emerge in the final 2 minutes before midnight. We are mere newborns in this stellar family. The system originated from a colossal cloud of gas and dust, a nebula, trillions of kilometers wide. At some point, the cloud's equilibrium was shattered, perhaps by a shockwave from a nearby supernova explosion. This surge of energy caused the cloud to collapse under its own gravity, initiating a rapid spin. At the center, the Sun ignited, becoming a dense, blazing core of hydrogen and helium. The surrounding material flattened into a spinning disk of debris, like a thin, cosmic pancake. From the slow, painstaking accretion of these particles, the planets, moons, and comets were born. This natural process yielded a surprisingly harmonious result. Orbits stabilized, planets settled at measured distances, some retaining light gases, others becoming dense, rocky bodies. This established the architecture we study today. The word system itself is key. It's not a mere collection of bodies floating in the void. It's a highly ordered, gravitationally bound structure. The Sun acts as the conductor, and the planets are the orchestra, each playing its line in a grand cosmic symphony. The orbits are precise and stable. The two worlds, inner and outer planets. Today, all bodies in the solar system can be broadly categorized into two distinct worlds, the inner system and the outer system. This distinction is based on more than just location. It reflects two entirely different types of planetary composition, structure, and history. The inner planets are those closest to the Sun: Mercury, Venus, Earth, and Mars. They are known as the terrestrial, Earth-like planets. They are relatively small, dense, with a solid, rocky surface. Their atmospheres are thin or absent. Why? Because during formation, they were too close to the burgeoning Sun, and its intense heat and solar wind stripped away most of their lighter gases. They are like scorched stones near a bonfire, dense, eroded, and baked. Beyond the asteroid belt lie the outer planets: Jupiter, Saturn, Uranus, and Neptune. These are the gas and ice giants. They are far more massive than their terrestrial counterparts, but consist mainly of gases like hydrogen, helium, and methane, rather than rock. They lack a true solid surface, possessing only incredibly dense clouds and, perhaps, hidden solid cores. Their atmospheres are deep and turbulent, their ring systems complex, and their numerous moons are worlds unto themselves. Our cosmic address, tucked away in the Milky Way. To grasp our place in the cosmos, picture our galaxy, a colossal, rotating disk with spiral arms, resembling a giant, star-studded seashell. This is the Milky Way, home to up to 400 billion stars. Our solar system is situated not in the bustling center, nor on the desolate edge, but on one of its spiral offshoots, the Orion Arm. It's like being in a quiet suburb of a massive metropolis, not too noisy, not too crowded. The perfect place to call home. We are approximately 27,000 light-years from the galactic center, and, along with the entire system, are rocketing around the galactic core at about 800,000 km/h. A single orbit takes roughly 230 million years. This means all of recorded human history, the age of the dinosaurs, and even the formation of the Earth, have all taken place in barely 1/10 of one single rotation. We are new kids on the block in this cosmic dance. The Earth advantage, a stroke of cosmic luck. Yet our solar system and the planet Earth are singularly special. The solar system is remarkably stable. Planets don't crash into each other. Their orbits are nearly circular. Our Sun is a medium-sized star, neither too hot nor too bright, but incredibly reliable. It doesn't flare violently or sputter out. At the third orbit out from this stable star is Earth. Here, all the cosmic ingredients have aligned perfectly. The existence of oceans, a protective atmosphere, and the very breath of life. We have the Moon, our steadfast companion, which stabilizes our axial tilt. We have Jupiter, the giant, acting as a cosmic bouncer, deflecting dangerous asteroids and comets away from the inner system. And we have a powerful magnetic field that shields us from the sun's harsh wind. Call it a coincidence or the elegant design of nature, but the fact remains, here, in this particular system, a creature emerged that could look back and ask, where do we come from? The revolution of understanding when early humans gazed at the night sky, they didn't see a solar system. They saw a mysterious pattern of stars and slowly moving lights, the planets. Everything seemed to revolve around them. It was a natural optical illusion. The Earth appears motionless, and the sun rises and sets. This led to the geocentric model, with a fixed Earth at the center and celestial spheres circling around it. This was the dominant view until the 16th century, codified by Claudius Ptolemy in the 2nd century AD. Then, everything changed. Nicholas Copernicus, a Polish astronomer, proposed a simple yet revolutionary idea. The Sun is at the center, and Earth is just one of the planets orbiting it. This heliocentric model explained observations with far greater elegance, but the world was not ready to relinquish its central position. However, the tide of knowledge was irresistible. In the 17th century, Galileo Galilei built a telescope and aimed it at the heavens. He saw that Jupiter had its own moons, proving that not everything orbits Earth. He saw that Venus had phases like the Moon, which is only possible if it orbits the Sun. He saw craters and mountains on the Moon, shattering the old belief that celestial bodies were flawless. These findings shook the world. Though forced to recant his views, the phrase attributed to him, "Eppur si muove," and yet it moves, has resonated through the ages. Later, Johannes Kepler demonstrated that planetary orbits are not circles but ellipses, with the Sun at one focus. Finally, Isaac Newton explained why they don't fall into the Sun or fly away. Gravity and inertia create a perpetual, stable balance between falling and motion. With every stride, humanity moved closer to the truth. We built observatories, charted the movements of the planets, and uncovered Uranus and Neptune. In the 20th century, the era of spaceflight dawned. We began not just to gaze at the planets, but to fly to them. Voyager showed us Jupiter and Saturn. James Webb now looks far beyond. We now know that the solar system is not the center of the universe, but it is our center, the crucible of life, and our point of observation. The beating heart. The Sun, the solar system, is a vibrant, breathing cosmic mechanism, and at its core is the Sun, the immense star that holds everything together. It is the pulse of our system, the heart radiating life. When we utter the word sun, we think we know it. We see it every day, but that is only an image, just the light piercing our atmosphere. The Sun itself is not just a disk in the sky. It is an ancient, perpetually burning star. It is a raging ball of plasma, millions of degrees hot at its center, with a surface that boils and throws matter into space at hurricane speeds. Yet, it provides life, shining just enough to warm us but not burn us, never fading, never exploding. How? The Sun is a main sequence star, meaning it's in the stable phase of its life. It doesn't burn with fire, it's powered by nuclear fusion. Roughly 75% of its mass is hydrogen, about 24% is helium, and the rest is heavier elements. Its diameter is nearly 1.4 million km, enough to line up 109 Earths across it. But the most staggering fact is its mass. The Sun contains 99.86% of the entire mass of the solar system. The planets, moons, and asteroids are mere crumbs circling a giant. How the Sun works. Deep within the Sun's core, temperatures reach 15 million degrees Celsius. The pressure is so immense that hydrogen atoms are squeezed together to form helium. This is thermonuclear fusion, the process where a fraction of mass converts into energy, the very mechanism encapsulated in Einstein's famous E = mc $2. Every second, the Sun converts about 4 million tons of matter into energy, yet it doesn't vanish because it is so vast. The energy born in the core takes hundreds of thousands of years to struggle its way to the surface, bouncing off particles like light in a thick fog. Then, it takes a mere 8 minutes to reach Earth. That is the sunlight that falls on your windowsill, feeds the leaves, drives the weather, and reflects in your eyes. All of it started deep inside the star. The Sun is layered. Energy is born in the core. Above that is the radiative zone, where energy travels as light. Then comes the convection zone, where matter churns like boiling soup. The photosphere is the surface we see, about $5,500 per circ. Text, see slurs. Above it is the chromosphere, a thin layer, and finally, the corona, the Sun's outer atmosphere, visible during a total solar eclipse. The Sun doesn't just shine, it constantly spews out a stream of plasma particles known as the solar wind. Sometimes dramatic solar flares occur, sudden, sharp bursts of energy and matter. If they hit Earth, they can cause spectacular auroras, disrupt satellites, and even knock out power grids. Fortunately, Earth is protected. Our magnetic field deflects most of these particles. We live inside a giant bubble of solar wind influence called the heliosphere, which extends far beyond the orbit of Pluto. The solar system's clock. The Sun is currently in its stable phase, having lived roughly half its life. It has about 5 billion more years left in this stage. After that, it will begin to swell, turning into a red giant, swallowing Mercury, likely Venus, and even approaching Earth's orbit. Eventually, it will shed its outer layers, leaving behind a white dwarf, a tiny, dense, cold remnant, the heart of a dead star. But that is billions of years away. For now, the Sun is stable, and every morning it reminds us, life goes on. The Sun is the source of all stories. It holds the planets in their paths, nourishes life, and dictates the rhythm of days and seasons. Without it, there would be no breath, no thought, no dreams. And it is in its shadow, on one of its orbits, that we live. In the next section, we'll move out to those bodies circling it, the planets. Each one is a chapter in a book, with its own climate, character, and history. Planet 1, Mercury, the speedy messenger. We approach the first planet from the Sun, the fastest, closest, and quietest. Mercury. This is a planet easily missed from Earth. It's so close to the Sun, hiding in its glare, that it's a tough catch even for a telescope. Yet it is one of the most ancient stones in our system's mosaic. Mercury's crust is remarkably thin, about 20 kilometers. Its surface is heavily pocked with craters from the intense bombardment by asteroids and meteoroids in the solar system's early days. One of the most stunning features is the Caloris Basin, an impact crater over 1,300 kilos in diameter. The force of the impact that created it was so immense that it caused chaotic terrain on the exact opposite side of the planet. Exploration of Mercury began with the Mariner 10 mission in the 1970s, which sent back the first detailed photos and discovered a magnetic field. The true revolution came with the Messenger mission in the 2000s, which orbited the planet, collecting data on surface composition, the magnetic field, and revealing countless geological features. Mercury is a window into the solar system's past. Its surface has barely changed over billions of years, preserving the scars of early planetary formation processes. Its unique structure and movement give scientists clues to understanding gravitational interactions, stellar influence on close-in planets, and the cooling of planetary cores. Next, we move to the next enigmatic world, Venus, where conditions are so harsh that it has rightly earned the name the Hell Planet. Planet 2, Venus, the runaway greenhouse. Venus is the second planet from the Sun and Earth's nearest neighbor, astonishingly similar to our planet in size and mass. It's often called Earth's sister planet, but the kinship ends with the numbers. Venus is a genuine cosmic hellscape, dominated by unbearable heat, corrosive acid clouds, and atmospheric pressure that could crush any terrestrial probe in minutes. Yet, behind this extreme facade lies a story that might tell us how Earth's fate could have unfolded if our planet's balance had been tipped. In terms of physical stats, Venus is almost Earth's twin. Its diameter is about 12,000 kilometers, only 5% less than Earth's. Its mass is roughly 82% of ours, and its density and gravity are also very close. If you stood on its surface, you would weigh almost the same as you do on Earth. Venus orbits the Sun at about 0.72 astronomical units, 108 million kilometers. It's closer than Earth, but not close enough to account for its outrageously high temperatures. The reason for Venus's catastrophic conditions is its unique atmosphere. The Venusian atmosphere is one of the most extreme in the solar system. It consists of 96% carbon dioxide, with small amounts of nitrogen and traces of sulfur compounds. The upper layers are shrouded in thick clouds of sulfuric acid, which completely obscure the surface. These clouds reflect up to 70% of the sun's radiation, making Venus appear so bright and brilliant in the night sky. Beneath these clouds, the planet's surface is a nightmare. Atmospheric pressure on Venus is 92 times that of Earth. This is equivalent to the pressure you would experience if you were 1 kilometer deep under the ocean. A human-made base there would be instantly squashed flat. The surface of Venus is the hottest of all planets in the solar system, with temperatures reaching 470 text. This is hotter than Mercury, despite Venus being further away. The primary culprit is the runaway greenhouse effect, which completely altered the planet's climate. In the deep past, Venus likely had more Earth-like conditions, possibly even liquid water. However, its proximity to the Sun led to a tipping point. As the temperature rose due to high solar radiation, the water evaporated. Water vapor, being a potent greenhouse gas, amplified the heat-trapping effect. Simultaneously, carbon dioxide, outgassed from intense volcanic activity, accumulated in the atmosphere, increasing its density and exacerbating the greenhouse effect until it spun completely out of control. Nearly 100% of the thermal energy reaching the planet is trapped by its dense, CO2 atmosphere. The upper acid clouds reflect about 70% of the incoming sunlight, but the 30% that penetrates is absorbed by the surface and cannot escape back into space due to the thick layer of carbon dioxide. This process turns Venus into a complete thermal trap. The temperature on Venus is stable across virtually the entire surface, with minimal fluctuation between the day and night sides or between the equator and poles. This is due to the extremely high atmospheric density, which evenly distributes heat across the whole planet. Even at night, temperatures remain roughly the same as during the day. Beneath the dense atmosphere lies an amazing world. The surface has been mapped using radar, as optical methods are useless due to the clouds. Venus is a planet of volcanoes. Its terrain is almost entirely covered by lava plains from past eruptions. The Maxwell Montes, the highest points, rise about 11 kilometers, taller than Mount Everest. Much of the surface is flat, but it is also marked by strange geological features called coronae, massive circular structures formed by magma activity deep below the crust. These coronae are signatures of powerful tectonic processes that occurred billions of years ago. Interestingly, despite the volcanoes, Venus shows no clear evidence of Earth-style plate tectonics. Instead, its crust seems to flex and buckle under magmatic pressure, creating unique relief forms. At an altitude of about 60 kilometers, incredibly powerful winds, up to 360 km/h, blow across the planet. This phenomenon is called superrotation, where the atmosphere circles the planet much faster than the surface itself. Venus takes 243 Earth days to rotate once on its axis, the slowest day of any planet, yet its year is only 225 Earth days. Thus, a day on Venus is longer than its year. Soviet Venera missions were the first to land probes on its surface, sending back data for less than 30 minutes before being overcome by the heat and pressure. Today, new missions like NASA's Da Vinci Plus and Veritas are planned to study Venus's surface and internal structure. These missions aim to answer the crucial question: could Venus have been habitable in the past? Next up is our home planet, Earth, Planet 3. Earth, the habitable oasis. What makes Earth stand out is liquid water. About 70% of our planet's surface is covered by oceans, seas, and rivers. Water is the foundation of life, and its unique properties, high heat capacity and ability to dissolve substances, make it ideal for sustaining biological processes. But why does Earth have liquid water when Venus and Mars do not? The secret lies in the planet's location. Earth is positioned in the habitable zone, or Goldilocks zone, around the Sun, the region where the temperature allows water to exist in its liquid state. If Earth were slightly closer to the Sun, it could have echoed Venus's fate. Further out, it would be a frozen desert like Mars. Equally vital is the magnetosphere, the magnetic field that shields our planet from the solar wind and cosmic radiation. Created by the movement of liquid iron in Earth's core, the magnetosphere acts as an invisible shield. Without it, the solar wind could have stripped away our atmosphere, as it did on Mars. Let's recall the solar wind, a continuous stream of charged particles constantly emitted by the Sun, traveling at speeds up to 800 km/s throughout the solar system. On Earth, it causes the spectacular northern and southern lights, auroras, as it interacts with the magnetosphere. Earth is a dynamic planet, its surface constantly reshaped by plate tectonics. The crust is divided into several large and small tectonic plates that float on the viscous mantle. These plates move, collide, diverge, and subduct, slide under one another, forming mountains, oceanic trenches, and causing earthquakes. Plate tectonics is crucial for the planet's cycles. For instance, Chartext SHA-TO, $2, released by volcanoes, helps maintain the necessary greenhouse effect to keep the planet warm. This constant resurfacing maintains the long-term stability of the planet. Volcanism also plays a key role, supplying new materials to the surface and releasing gases like Chartext CO $2 and water vapor, which influence the climate. Earth's atmosphere is another unique feature. Its composition is perfect for supporting life. About 78% nitrogen, 21% oxygen, and small amounts of Chartext CO $2 and other gases. This balance is no accident. It was formed by billions of years of biological and geological processes. Oxygen appeared thanks to ancient microbes that began to produce it through photosynthesis. This event, known as the Great Oxidation Event around 2.5 billion years ago, completely changed the planet's chemistry, making it suitable for complex life. Chartext CO $2, though a tiny fraction, is crucial. It regulates the planet's temperature through the greenhouse effect, preventing the Earth from freezing over. This delicate balance makes our planet comfortable, but also vulnerable. Any serious change in Chartext $2 concentration can lead to climatic disaster, as happened on Venus. Earth's companion, the Moon. We cannot discuss our planet without mentioning our faithful companion, the Moon. At about 3,470 kilograms in diameter, the Moon is the largest satellite in proportion to its planet in the solar system. First, the Moon stabilizes Earth's axial tilt. This keeps our planet's tilt relatively constant, ensuring stable seasons and climate. Without the Moon, Earth's axis might wobble much more drastically, causing chaotic climate swings. Second, the Moon causes the tides. These cyclical movements of water in the oceans were vital in the evolution of life, as scientists believe tides may have facilitated life's move onto land by providing organisms with an environment to adapt to different conditions. Third, The Moon has served as a cosmic shield for Earth, taking the brunt of asteroid and meteor impacts in the solar system's early history. By studying Earth, we not only understand its uniqueness, but also recognize the fragility of our home. The next planet we examine is Mars, our closest neighbor, which may hold the keys to Earth's past and humanity's future. Planet 4. Mars, the Red Hope. Mars has captivated humanity since ancient times. Its reddish hue in the night sky inspired myths and associations with war. But today, Mars symbolizes not war, but hope. It has become our window into the solar system's past and potentially the future of human exploration. Planet 4. Mars, the Red Hope. Continued. Mars is the fourth rock from the Sun, coasting at an average distance of 228 million kilometers, about 1.52 AU. This placement means it receives significantly less solar warmth and light than Earth does. In terms of sheer size, Mars is roughly half the diameter of Earth, with a surface area comparable to the total dry land mass of our planet. Its total mass is only 11% of Earth's, and its surface gravity is a mere 38% of what we feel here. So, if you were a 70-kilo Earthling, you'd be a featherlight 26-kilo Martian. Mars is essentially a frozen, rusty desert. The planet's average temperature hovers around 63°C text, but due to its paper-thin atmosphere, temperatures swing wildly, from a bone-chilling 125°C text at the winter poles to a relatively balmy +20°C text on the equator during summer days. This extreme fluctuation is a consequence of the wispy air, which is incapable of retaining heat. The Martian atmosphere is so rarefied that its pressure is a scant 0.6% of Earth's. This is the equivalent of standing 30 kilometers above our own planet, an altitude where commercial jets would struggle. It is composed of 96% carbon dioxide, with traces of nitrogen, argon, and water. One of Mars's most dramatic features is its global dust storms, which can completely envelop the entire planet. These storms whip fine dust into the air, blotting out sunlight and making Mars even colder. The massive 2018 storm, for instance, lasted for months and tragically led to the demise of the Opportunity rover. Yet the Martian surface is truly breathtaking. Its rust-red wastes, due to oxidized iron, colossal volcanoes, dried-up ancient riverbeds, and icy polar caps all tell the story of a planet that was once a vastly different world. Imagine Olympus Mons, the tallest volcano in the entire solar system, standing at 22 kilometers high. That's 3 times the height of Mount Everest, with a base so immense you couldn't see its peak from the ground. Or consider the Valles Marineris, a vast canyon network stretching 4,000 kilometers long and up to 7 kilometers deep, 10 times longer than the Grand Canyon and 4 times deeper. Scientists believe these gigantic features were carved by tectonic processes and, possibly, by the powerful flow of water that once coursed across Mars. Water is the Rosetta Stone of the Martian mystery. Today, no liquid water exists on the surface, but the traces of its past presence are everywhere. Billions of years ago, Mars was warmer, its atmosphere thicker. Rivers flowed, lakes formed, and an ocean may have covered a significant portion of the northern plains. Now, Martian water is trapped as ice in the polar caps or locked beneath the surface. However, strong evidence suggests that subterranean lakes of liquid water, kept warm by geothermal activity, might still exist, especially near the South Pole. These findings are the beacon of hope for the past existence of life, and perhaps for microbial life even now hiding deep underground. Today, Mars is the prime target for cosmic exploration. Rovers like Curiosity and Perseverance tirelessly study its geology, collecting data on the climate and searching for signs of ancient life. Curiosity confirmed that Mars was once habitable, and Perseverance is currently exploring the Jezero crater, the site of an ancient river delta where microbial life could have flourished. But human ambitions don't stop there. Visionaries like Elon Musk and SpaceX dream of sending the first humans to Mars in the 2030s to begin the long-term project of establishing the first off-world colony. Our next stop is Jupiter, the king of planets, which will unveil a completely different kind of cosmic realm, the reign of the giants, Jupiter and Saturn. Our solar system odyssey continues as we leave the zone of the rocky planets and head for the territory ruled by the giants. Stretching between Mars and Jupiter is the asteroid belt, a region densely packed with millions of rocky and metallic objects that were unable to coalesce into a full-fledged planet. Scientists blame this failure on the massive gravitational juggernaut of Jupiter. Planet 5. Jupiter. The cosmic bouncer Jupiter is the most massive and mysterious planet in the solar system. It is so vast that it could comfortably contain over 1,300 Earths inside it. Its gravitational influence extends far beyond its orbit, not only governing its own system of moons, but also acting as a cosmic shield, sweeping up or deflecting dangerous asteroids and comets that might otherwise threaten Earth. Jupiter is a world of colossal storms, crushing pressures, and a magnetic field that engulfs space for millions of kilometers. Its most famous features are the perennial Great Red Spot, unbelievable auroras, and its 4 largest Galilean moons, each a potential world in its own right. Its mass is more than 318 times that of Earth. Surprisingly, if it kept adding matter, it wouldn't get much bigger. At a certain point, gravity would simply cause it to compact into an even denser sphere. Jupiter's gravity is 2.5 times stronger than Earth's. However, you couldn't stand on Jupiter's surface because there is no surface to speak of. Jupiter is composed mostly of hydrogen and helium, much like the Sun. Descending through the outer clouds is a journey through layers of increasingly dense gases. First, the swirling atmosphere of ammonia and methane, featuring hurricanes spanning thousands of kilometers. Then, the pressure mounts so tremendously that the hydrogen becomes liquid and then metallic, a substance achievable on Earth only in high-pressure labs. This ocean of metallic hydrogen, tens of thousands of kilometers deep, conducts electricity. This is the engine that generates Jupiter's incredibly powerful magnetic field. Deeper still, there may be a small, rocky core about 10 times the size of Earth, but scientists are still debating this. It's possible the core has partially dissolved into the liquid hydrogen due to the colossal pressure. Jupiter is defined by its turbulent atmosphere and characteristic bands. These light zones and dark belt stripes are the result of powerful winds that rage in opposite directions at speeds up to 600 km/h. The entire atmosphere is a boiling ocean of gas where constant vortices create intricate patterns. Lightning flashes are thousands of times brighter than on Earth. And of course, the Great Red Spot. This colossal storm is a true veteran, having raged for at least 350 years. Today, the hurricane is about 16,000 kilometers across, still several times the diameter of Earth, though it has been slowly shrinking. Scientists don't know if it will ever disappear entirely, but this monster storm remains one of the solar system's most awe-inspiring phenomena. Jupiter's magnetic field is the most powerful of all planets, up to 20,000 times stronger than Earth's. It creates a colossal magnetosphere so vast that if it were visible, it would appear larger than the Moon in our sky. Jupiter is a true radiation inferno. Streams of charged particles rage around it, and the radiation in its vicinity is lethal even for highly shielded spacecraft. Jupiter is a system unto itself, with over 80 moons. The four most famous are the Galilean satellites, Io, Europa, Ganymede, and Callisto. Io is a volcanic hellscape, the most geologically active object in the solar system. Its volcanoes constantly spew plumes of lava and sulfur tens of kilometers high. Its interior is heated by the gravitational tug-of-war between Jupiter and its other large moons. Europa is a world under the ice. Its surface is covered by an icy crust, but beneath it lies a massive ocean of liquid water, its volume greater than all of Earth's oceans combined. Cracks caused by Jupiter's tidal forces scar the surface, and plumes, geysers of water, jet into space. If life exists anywhere else in the solar system, Europa is a top candidate. Ganymede is the king of the moons. It is larger than the planet Mercury and is the only moon in the solar system with its own magnetic field. Callisto is an ancient, heavily cratered world, one of the oldest objects in the solar system. The future of Jupiter exploration is bright. NASA's Juno mission is currently studying its atmosphere and magnetic field, and the Europa Clipper is scheduled to investigate Europa's icy surface to confirm the presence of its subsurface ocean and the potential for life. Planet 6, Saturn, the jewel of the system. Jupiter is the powerful king, but its neighbor Saturn is its aristocratic counterpart, surrounded by the most stunning ring system that makes it truly one of a kind. Saturn is the second largest planet. Its diameter is about 9.5 times that of Earth. Despite its gargantuan size, Saturn is the lightest planet of all. Its average density is less than that of water. If you could find an ocean big enough, Saturn would float. Its crowning glory is its majestic rings. When we see photos, the rings appear solid and continuous, but this is an optical illusion. They are actually composed of billions of particles of ice and rock orbiting the planet. These particles range in size from fine dust grains to chunks the size of a house. The ring's thickness is incredibly shallow compared to their width, only about 10 meters on average, while their diameter exceeds 200,000 kilograms. It is a giant, flat disk, so thin that it practically vanishes when viewed edge-on. Scientists still lock horns over the ring's origin. One theory suggests they are the remnants of a moon that wandered too close and was shredded by Saturn's gravity. Another posits they are simply material that failed to coalesce into a full moon. The rings feature fascinating structures, such as the Cassini division, a massive gap nearly 4,800 km wide. The culprit here is Saturn's moon Mimas, whose gravitational influence clears out the particles in that region. Like Jupiter, Saturn's atmosphere is a mix of hydrogen and helium, giving its clouds yellowish, golden hues. While Jupiter has the red spot, Saturn boasts an equally mysterious feature, the hexagonal storm on its north pole. Imagine a colossal hurricane, 25,000 kilometers across, which takes the strict geometric shape of a perfect hexagon. Winds inside this anomaly rage at over 500 km/h, and its edges remain astonishingly sharp. But Saturn is a system of 83 moons, none more fascinating than Titan. Titan is the second largest moon and the only moon with a dense atmosphere. If you stood on its surface, the sky would be a thick orange-yellow haze. Most bizarrely, Titan experiences rain, but it's rain made of liquid methane and ethane. At 180 circ, text, see smod sir. Water is as hard as rock here, and the rivers, lakes, and seas are filled with hydrocarbons that remain liquid at these extreme temperatures. This world is a curious analog to Earth, with seasons, clouds, and precipitation. Enceladus, another moon, is striking for its geysers. The Cassini probe discovered that jets of water are erupting into space from its south pole, forming one of Saturn's outer rings. Underneath its icy crust is a subsurface ocean of liquid water. Furthermore, the plumes contain organic molecules and chemical traces that could provide energy for life. This makes Enceladus, alongside Europa, a prime contender in the search for extraterrestrial life. The most detailed exploration of Saturn and its moons was conducted by the Cassini-Huygens mission. The Huygens probe successfully landed on Titan, becoming the first craft to land on a moon other than our own. The deep freeze, Uranus and Neptune. Beyond Saturn, our journey continues into the depths of the solar system, where the world of the ice giants begins. Planet 7. Uranus. The planet on its side, Uranus, the seventh planet, is unique. It's blue, mysterious, and spins on its side, surrounded by faint rings and moons with bizarre geology. Its cold, harsh atmosphere hides secrets that remain poorly understood. Uranus, along with Neptune, belongs to the category of ice giants. While Jupiter and Saturn are mostly hydrogen and helium, the ice giants contain far more heavier elements like water, ammonia, and methane. Instead of an ocean of metallic hydrogen, Uranus has a massive layer of ice made of these compounds beneath its cloud tops. If you could dive into Uranus's atmosphere, you would pass through methane and hydrogen clouds before the gases compress into liquid and icy layers. There is no true solid surface to stand on. Uranus is one of the coldest planets in the solar system, with an average temperature of 224 circ. Text, see colder than even the more distant Neptune. This is because Uranus releases almost no internal heat, unlike the other giants. Uranus's most extraordinary feature is its bizarre rotation. Unlike all other planets, which spin more or less upright, Uranus is tilted by 98 circ dollars. It literally rolls along its orbit, causing its poles to face the sun for decades at a time. This results in the most extreme seasons in the solar system. One pole faces the sun for 42 Earth years straight, followed by 42 years of complete darkness. Scientists believe a massive object, perhaps an Earth-sized planet, slammed into Uranus during its formation, knocking it on its side. The 2% methane content in its atmosphere gives Uranus its pale blue color, as methane absorbs red light and reflects blue and green. The planet is home to strong winds, reaching speeds of 900 km/h. The only spacecraft ever to visit Uranus was Voyager 2 in 1986. Since then, no mission has returned, though NASA is planning a new orbiter mission for the 2030s to fully study the atmosphere, moons, and internal structure. Planet 8. Neptune, the Storm King. Our journey reaches the last known giant, Neptune. It is the most distant, the windiest, and arguably the most enigmatic. If Uranus is the quiet, cold world, Neptune is a fierce, stormy giant that harbors the most powerful hurricanes in the solar system. Neptune is another ice giant, with a more dynamic and active atmosphere than Uranus. It has the same blue color, but its defining feature is its winds. Neptune has the strongest sustained winds in the solar system, reaching speeds of 24,100 km/h, faster than the speed of sound, and 3 times more powerful than the fiercest hurricanes on Earth. Scientists are still baffled as to how Neptune, which receives only 1/9 the sunlight of Jupiter, maintains such a turbulent atmosphere. Neptune, too, has its own gigantic storm, the Great Dark Spot. When Voyager 2 transmitted the first images in 1989, scientists saw a massive dark vortex akin to Jupiter's red spot. Yet a few years later, when the Hubble telescope looked again, the dark spot was gone. It had simply dissipated. New dark spots, new gigantic hurricanes, appear and vanish in Neptune's atmosphere every 5 to 10 years. Neptune, like Uranus, has no clear surface. It has a thick layer of icy mantle, water ice, ammonia, and methane, covering a hot, dense, Earth-sized core of rock and metal. This hot core is thought to help drive the powerful winds and atmospheric activity, as Neptune radiates twice as much heat as it absorbs from the Sun. Among Neptune's 14 moons, Triton stands out. It is the largest moon and one of the strangest objects in the solar system. Its key characteristic: it orbits backwards, retrograde, compared to the planet's rotation. This means it was not formed with Neptune, but was likely captured by its gravity from the Kuiper Belt, a region of frozen objects beyond Neptune. Triton is covered in frozen nitrogen, making it one of the coldest places in the solar system. 235's Circuit text, Sitzplan. Yet Voyager 2 found icy geysers shooting jets of nitrogen from the surface. This suggests a heat source deep inside, raising the possibility of a subsurface ocean of liquid water, putting Triton on par with Europa and Enceladus in the search for life. The fringes: asteroids, dwarf planets, and comets. Our tour of the major planets is over, but the system doesn't end here. Beyond Neptune lies the Kuiper Belt, hiding thousands of icy worlds like Pluto, Haumea, and Eris. In between and beyond the giants lies a whole zoo of smaller bodies: asteroids, comets, and meteorites. These objects may seem insignificant, but their role in the system's formation and evolution is immense. They are the fossil record of the solar system's distant past, and some pose a potential threat to Earth. The asteroid belt between Mars and Jupiter is a testament to the powerful gravitational influence of the King of Planets, which prevented this material from coalescing into a full planet. Asteroids vary wildly, from giants like Vesta to tiny fragments. They consist of metals, silicates, and carbon compounds, and some even hold water. Beyond their scientific value, asteroids pose a real-world threat. We know that 66 million years ago, one of them struck our planet, causing the extinction of the dinosaurs. Today, astronomers diligently track near-Earth objects, NEOs. Large ones are safe, but smaller objects remain a concern. This is why agencies like NASA are developing planetary defense methods, including the DART mission, which successfully altered the orbit of a small asteroid in 2022. For a long time, Pluto was considered the 9th planet. In 2006, it was reclassified as a dwarf planet, sparking intense controversy. The key reason for the demotion is that Pluto does not dominate its orbit. It shares its space with other large objects in the Kuiper Belt. However, Pluto remains fascinating. It has 5 moons, the largest of which, Charon, is so big that they form a binary system, orbiting a common center of mass. Pluto's surface features icy plains and cryovolcanoes that erupt liquid nitrogen and methane instead of lava. When the New Horizons probe flew past in 2015, It transmitted images that stunned scientists, revealing this little world to be far more complex and geologically active than anyone expected. If asteroids are the solar system's rocks and metals, comets are its dirty snowballs. They contain water, frozen gases, and organic molecules. As they approach the sun, they begin to vaporize, forming the spectacular tail, which is always directed away from the sun by the solar wind. Comets originate from two main regions: the nearby Kuiper Belt, source of short-period comets like Halley's Comet, and the vast Oort cloud, a spherical shell at the solar system's outermost edge. Some scientists believe comets were the original carriers of water, and perhaps even the organic molecules necessary for life, to the early Earth. And what about meteorites? These are small fragments of asteroids or comets that fall to Earth. Most burn up in the atmosphere, creating the beautiful effect of a shooting star, but some make it to the surface. The most famous recent example is the Chelyabinsk meteorite, which entered the atmosphere in 2013, creating a shockwave that shattered thousands of windows. The journey's end. Stardust, we have traveled from the sun's blazing heart to the icy borders of the heliosphere. We have flown over Mercury's craters, through Venus's clouds, and glanced back at Earth from light minutes away. We witnessed Jupiter's storms, Saturn's rings, Uranus's strange tilt, and distant blue Neptune. We zipped past comets, asteroid belts, and the forgotten orbits of Pluto. This is not just a collection of planets. It is a history of matter. It is our deep time route. As we reach the end of this journey, remember that everything we have seen was once dust, and that dust became stars, planets, and us. We are children of the stars. We carry calcium in our bones, born in the hearts of dying stars. We breathe oxygen forged in ancient stellar processes. Our thoughts are composed of carbon, formed billions of years ago in other galaxies. The cosmos is not out there, it is within us. Now, as you close your eyes, imagine the night outside. It is not mere darkness, it is the universe. Perhaps right now, on the other side of the galaxy, someone is looking at our sun as a distant star. Perhaps someone dreams of touching the rings of Saturn, just as we dream of the Andromeda Galaxy. Perhaps everything repeats, or perhaps everything is just beginning. If you look at the sky tomorrow, you might just know where your home is. Among all those distant stars, among all those impossible distances, there is a tiny point where a soft, steady light burns. It is called the sun, and orbiting around it is the Earth, and on it is you. Thank you for spending this night with us. May you dream of the sky, and may you once again fly through the solar system, slowly, freely, and peacefully. Until our next nocturnal voyage.